Good morning, everyone. Good morning. Hope all is well. Of course, we're waiting for everybody to get in.
Good morning.
Good morning. All right. So I think I see one or two. So just give them a second.
I have a quick question.
Mm-hmm.
So I've been trying to get in contact with you, but I wasn't sure what the email was because I obviously have it wrong.
All right. Let me see. Let me see. When do you know when you sent your email?
This morning.
Oh, well, I know I haven't looked at anything this morning. But let me see. All right. Yeah. I see one that you sent this morning,
Okay.
but I hadn't looked at anything this morning. So
Okay, cool. All right. I just wanted to make sure I was able to get in contact with you.
okay, cool.
Thank you.
I'll look at it. Yeah, most definitely. Thank you. I'll look at it and respond back.
Okay, thank you.
All right. Let's see. Is everybody in here? Let me look at one other thing before we get rolling. I forgot to look at before. Right. All right. So hope everybody had a great weekend. Everybody's doing all right, and everybody's um, ready to get this weekend started, and not get this weekend started, but get this week started, and ready to roll. So, looking at my math lab stuff, I see, there were a few people who didn't get a chance to knock out all the chapter one's content. So what I can do, I'll give you guys an extension till Sunday. But yeah, got to get that stuff in there. And the reason why there has to be some type of, market, because everything builds upon the next thing. So if I just had it open, and I've tried these different things. So if I just had it open, then people be in all different types of places. But when we start getting into heavy into chapter two's things, it's just like, but you're still missing chapter one's content and chapter one's foundation for chapter two, which is foundation for chapter three, and so on. So we need to put these markers in here so that it'll push you to get out of chapter one, so that you cover the stuff that's in there, so you can be ready for chapter two, chapter three, and most definitely chapter four, which is leaning on all of them. So yeah, I'll open that up probably right after this class once we get out of here, and I'll go from there. Also, if I missed any emails, I'm planning on getting caught up on those today. So if you did send me something over the weekend, had a lot of stuff going on, and but I'll get caught up and respond to any emails that were sent. Someone said, "How was the test review graded?" Your test review is extra credit. Test reviews are not mandatory. But if you score 85 or better on it, I will add 5 points to your actual test. Yep, so that's how your test reviews are seen. Once again, they aren't mandatory, but what I would suggest is that you at least take a look at them and see what type of problems will be on the test, so it can help you streamline your studies. All right. Yep, not a problem. Anything else, anybody else before we get going? Very good. So once again, that. Mhm.
I'm sorry.
Sorry.
So my email was actually about, I still can't get into math lab, so I've
Okay.
been struggling to do
Okay,
that.
stay after class and let's see if there's anything I can do to help you out with that.
Okay, thank you.
I think I heard another voice.
Yeah. I missed. You said something about if you take the practice, how many points you get to your test?
5.
Oh, okay. That's what I was wondering. Okay.
Yep, no problem. Anything else? Anybody else? All right, so I believe, yep, last class we did 2.1. So we will start with 2.2 today. All right, so 2.2, more of functions. So when your function is considered increasing, on an open interval. That's as x value increases, the y value increases. In other words, as you read it from left to right. So, you know, when you're reading it from left to right, if your line goes up, then that's considered increasing. And then decreasing would be the opposite, going from left to right. As x increases, excuse me, y decreases. So that means your line will be going down. So that's considered decreasing. All right, everybody still holding on to increasing? All right, so constant on an open interval means that as x increases, the y value stays the same. All right, can I scroll up on decreasing? All right, so our first example, they want us to state the intervals on which each is increasing, decreasing, or constant. So let me erase some of the stuff. Anybody still holding on to constant? Okay. All right, so this is our graph right here. They want us to state the intervals, the open intervals in which each is increasing, decreasing, or is constant. So notice in red, I put a note there that we're going to use the x values to establish our intervals. So remember, we're going from left to right, horizontal are your x values, the x components of your order pairs. Excuse me. So when we write these intervals, we're not going to be using our y values. All right. So notice that we have this point here at 2. Well, not say 2, but -2. And then right here at +2. So those are going to be our markers for our intervals. Now, if we follow this from left to right, remember we're going this way, left to right, not going down, this way, no, the whole thing is going to be from left to right as you flow. So from left to right, we're coming from negative infinity. And let me say it like this. Remember, we're coming in this direction. We're not talking about down negative infinity. We're talking about from the left. And we're coming to -2. And we're going up. So that means we're going negative infinity to -2, increasing. We're going up. So negative infinity to -2. All right. So then this way, from left to right, that's going to be constant. It's level. We're going -2 to +2. And then here from left to right, we're going down, following our graph going down. So that will be +2 to infinity. Because remember, we're not talking about, this as our infinity. We're talking about going to the right. Your right, positive infinity. And so that's how you set up your intervals. All right, questions on that one before we look at another one? Can I scroll up? All right. So the next one, looks like we have a cubic equation or some form of it anyway. Maybe just odd power. Anyway, it doesn't matter. So if we know we follow from left to right, oh, my bad. Keep my wrist on. Notice we're going down. So we're coming from negative infinity. And we're talking about from the left. Left over here is from negative infinity. We're coming from negative infinity to 0. That's what this point is for x. Then we're going up to positive 2. So that means that's going to be from our increasing interval, that's 0 to 2. Remember, all of our intervals are set by our x values. What would our x value be at this point? That's going to be 2. All right, so we're only using our x values. Then we go down as we move towards positive infinity, or as we move towards the right, we're going down. So we use the union symbol here, 2 to infinity. Now there's no constant interval here, so you can just write 9 for that.
On MATLAB, will it ask you to have a constant if there isn't a constant?
I don't think so. I'm just doing that for note purposes. I don't believe they'll do, if it's not there, then you wouldn't have to put anything in there for the box or whatever the way they got it set up. Yeah.
Okay.
Yeah, I believe there will only be, you only have to put in for that. If there's anything, then there will be an option. Click, there is no interval. It wouldn't be anything for you to type in. All right. Oh, so any questions on that? So those questions may show up when you actually try those out. So just try them out. If you have any questions on any of them, of course, feel free to bring them to class and we can, pull up your screen or whatever the case may be and make sure we have an understanding on the shape that you see, the pattern that you see. But those are your 3 intervals, increasing, decreasing, constant. And we're going from left to right, only using your x values to set up those intervals. Notice we only use parentheses as well because these are open intervals. All right. I'm going to scroll up. So relative extrema, for those of you who may be going to calculus, this is something that pops up, your relative extreme values. And you're talking about your maximum or minimum values relative to an interval. In other words, they can be the largest or smallest values in a certain open interval, but it may not be the largest or most extreme value for that whole function. So when you look at this example down here, this would be a relative max, this would be a relative min, but that's not our most extreme or largest value because it goes up to infinity. And this wouldn't be the smallest value because it goes down to infinity. So, finding these relative maximums, relative minimums will help us when it comes to, whether it be us trying to figure out this graph or figure out different peaks and valleys in a certain application. That's where these come into play.
So it's basically the next lowest thing to infinity.
Well, it just depends on the graph. If I had, let's go here back to this. Let's say if my interval um, is from here, let me use something more prevalent. It's from here to here, and these green dots. Then my relative max would be this point, and my relative min would be this point. It's just the largest and smallest value in that interval. So it just depends on what interval you set up, or like I said, when you're dealing with calculus, what interval you're being asked about. Now, I will say this though, if they do ask that generically about something like this, then that would be the best way to look at it. In other words, if I have going to positive infinity and negative infinity, what is the highest value outside of that? Then yes, you would go that route. Mm-hmm.
Thank you.
Yep, no problem. Now they don't focus much on that. They mention it, talk about it. At most, I think there may be a question that asks you to use your graphing tool to find the relative maximum in. But if you see that, then feel free to ask me on if you don't know how to use a graphing calculator, or don't forget you have all types of free graphing tools. Just if you Google graphing calculator, graphing tool, or relative maximum in, like there's a whole bunch of free stuff that you just type in the function and it'll give you the relative maximum in. So they really don't do much on that, but he mentioned it just so you have an understanding of what it is. But yeah, if you come across something like that, yeah, you want to, talk about it, let me know. But like I said, I don't remember, much, as far as the problems are concerned. All right, so here, looking at symmetry, definition of symmetry, and then testing for symmetry. So symmetry with respect to the y-axis, for every point on the graph, the point negative xy is also on the graph. So the way we'll test for symmetry with respect to the y-axis is substitute negative x for x in the equation. And if it results in an equivalent equation, in other words, you plug in negative x, simplify, if it gives you what you originally had, then that means it is symmetric with respect to the y-axis. And, we got a couple examples in which we'll try this out. So hold on to the back. All right, so symmetric with respect to the x-axis, for every point on the graph, the point x negative y is also on the graph. So you're going to substitute in negative y for y. And if when you simplify, you have the original equation, then it is symmetric with respect to the x-axis.
Professor Tucker, can you go up a little?
How far you?
Just up, right there.
right, can I scroll up? Anybody still holding on to the first one? All right, and the last one, being symmetric with respect to the origin. So for every point on the graph, the point negative x, negative y is also on the graph. So I'll scroll up for that test in a second, where basically you'll plug in negative x for x, negative y for y, and then, okay, not a problem at all. And then if you get your original equation, that means it is symmetric with respect to the origin. All right, can I scroll up? I'm done with the black right there. Okay. And we'll get ready to try this out as soon as you guys finish. All right, can we scroll up? Oh, let me do this. All right, is anybody still copying with respect to the origin? All right, so we want to determine whether the graph of x equal to y squared minus 1 is symmetric to the y-axis, symmetric to the x-axis, or to the origin. All right, so we're going to run all three of those tests that I just mentioned on this one function, x equal to y squared minus 1. All right, so once again, this is our original equation, x equal to y squared minus 1. The first test I want to do is symmetric to the y-axis. That was the first one that I wrote. So in order to test symmetry with respect to the y-axis, we're going to substitute in negative x for x. All right, and that's what we did right here. So I plug in negative x where I saw x. So that would leave us with, if I were to erase that, negative x equal to y squared minus 1. So I want to set it up this same way. In other words, I want to have x equal to and see what my result is. I want to make a clean comparison. So I'm going to set this up and let it be in the same form. So I'm going to multiply both sides by negative 1. And my result is x equal to negative y squared plus 1. So my conclusion, since this is not the original equation, the function is not symmetric with respect to the y-axis. So when you simplify this thing out, you plug in your negative x for x. Like I said, I went ahead and multiplied both sides by negative 1 just so I can make a clean comparison. X is equal to, just like I have this is set up, x equal to y squared minus 1. Set this one up, x equal to. That's why I multiply both sides by -1. When you do that, we see x is equal to -y² plus 1. That is not my original equation. The original equation was y² minus 1. So once again, that last statement, since this is not the original equation, the function is not symmetric with respect to the y-axis. All right, any questions on that first one? All right. And we scroll up, go to the next one. All right, next test, symmetric with respect to the x-axis. So if you go back and look at that one, the way we would do that is to substitute -y in for y. So I'll plug in -y into that original equation right here. So -y², don't forget -y times -y will be positive y. And so that would be x equal to y² minus 1. And then the statement for this conclusion, since this function is the same as the original, it is symmetric with respect to the x-axis. All right, any questions? All right, last one, symmetric with respect to the origin. This time we're going to substitute -x in for x, -y in for y. See if we get the original equation. So we already did both of them individually, so we know the effects of the negative that we'll have on it in each case. So we know -y² is just going to be positive y². Then that -x, if I multiply both sides by -1, I get this as my equation. And since this function is not the original, it is not symmetric with respect to the origin.
Can you explain to me why the y is still negative in the very end of that problem?
Because we multiply both sides by -1.
Oh,
Yep.
I didn't even see that. Thank you.
It's all good. Not a problem. Yep, that's the only reason why, but yep. All right, any questions on those three questions or anything that we did? All right, anybody still copying? All right, so Next thing, even functions versus odd functions. Similar to what we just finished doing, your even functions are functions that when you plug in negative x and you simplify, you will get the original function. Odd functions is when you plug in negative x and you simplify, each sign is going to be opposite of the original function. All right, so determine whether the function is even, odd, or neither. So it'll give us different functions, and we need to plug in negative x, see what the result would be. So the first one, we have f of x is equal to x cubed minus 6x. So once again, we're going to plug in negative x for x, then simplify. If what we have as a result is the original function, then it's an even function. If each sign is opposite, then it's odd. Okay, and if neither happens, and if there's like a mixture, then it's neither. All right, so now this is going to lean on your understanding of, odd powers to a negative number versus even powers to a negative. So in other words, when we talk about right here, if I'm looking at -1 squared, negative times negative will give you positive. Well, as long as your power is even, it's always going to result in positive. Whether it's -1 raised to the 100th power, that's going to be a positive result. Because your negatives will cancel. So that's why I was saying down here with -1 to the 400th power will still be +1 because it's an even power. Those negatives will cancel. Now, if you take -1 to the 3rd power, though, 2 of those negatives will cancel, but a -1 will be left over. So that's why the result will be negative. So any odd power will leave a negative number. All right. And so that's what I was saying right here with -1 to the 505th power will still leave you with -1 because you still have that odd number left over of negatives. So like I said, it's leaning on that understanding that, if I raise a -1 to an even power, the result will be positive. If I raise -1 to an odd power, the result will always be negative. So plugging in -1 here, not -1, but negative x here, I have negative x cubed minus 6 times negative x. Hold on 1 second. Sorry about that. So -1 cubed is on negative. I keep wanting to say -1. Negative x cubed will reduce down to negative x. Once again, because it's odd, you still will have a negative left over. And then -6 times negative x will give you a positive 6x. So before we go to our conclusion, is everybody okay with that simplification? All right, so here, since each sign is opposite the original function, it is odd. So we have negative x cubed before we had positive x cubed. Then we have positive 6x before we had negative 6x. So since each sign would be opposite of what we originally had, that means it is odd. All right, scroll up. All right, so same thing for this function. We have x to the 4th minus 2x squared. We're going to plug in negative x and see what our result will be. So we're plugging in negative x right here. And here we have even powers being applied to that negative. that means the result will be positive. So we have x to the fourth minus 2x squared. Now this negative 2, has nothing to do with our powers. That was already there. We're talking about this negative being affected by your squared. So just want to throw that out there. So x to the fourth minus 2x squared is what our result is. And this function is the same as the original. So that means it is an even function. Any problems? Then the last one, same practice or process, plugging in negative x into each place that we see x. And here, negative x squared will be positive x squared. Then here, that negative x times 2 is just going to be negative 2x. Excuse me. And then it's plus 1 in the back. So we compare it to our original. All signs are not the same. Neither are all signs opposite. So this function is not either, or is neither even or odd. I should say it's neither either or odd. But anyway, not even or odd. Yeah, either one will be fine. But yeah, so the function is not even or odd. Any questions? All right, got one more thing in this section. Can I scroll up before or can I scroll up? Yeah. Yeah. All right, so last thing in this section, our difference quotient, something that you will use in calculus, another calculus situation, something you can use to find your slope when the normal situations aren't available to you. We have f of x plus h minus f of x over h. The applications of your difference quotient isn't used in the section or in this class at all, but it introduces it so that when you get to calculus, it won't be the first time that you've seen it. All right, so let's look at f of x equal to 2x squared minus x plus 3. We want to find the difference quotient. So notice we have f of x. Right, f of x is equal to 2x squared minus x plus 3. So we don't have to find f of x. They give you f of x. But what you do need to find is an algebraic representation of f of x plus h. So we're going to take x plus h and plug it in where we see x. So that's always your first move. Just want to reemphasize the process. They give you f of x. They have to define what f of x is. Your next move is to plug x plus h in for x, and then simplify from there. So this is what we have. 2 times x plus h squared minus x plus h plus 3. All right. So first we need to recognize that right here, x plus h is a binomial multiplication, binomial distribution. That's x plus h times x plus h. That's what I did right here. Where you have to fold that out, x times x times h times x, h times h. So the result would be x squared plus 2xh plus h squared. And then also right here, we're going to distribute that negative. So don't forget to distribute the negative to both terms inside of that parentheses. After you expand out x plus h squared, then you can distribute 2. So that's 2x squared plus 4xh plus 2h squared minus x minus h plus 3. So before we go any further, make sure we're okay with how we got to what's in the box. All right. Now we're going to use a formula. Once again, we had x of x. Now we have f of x plus h. And so we're going to put those two expressions together with the minus sign in between, just the same way that we see it. And this is what we have. So that's 2x squared plus 4xh plus 2h squared minus x minus h plus 3. That's that first quantity of f of x plus h minus f of x, which is 2x squared minus x plus 3. And all that's still over h. All right, so now we're going to combine our like terms. First thing we would do, though, is distribute that negative that's sitting in front of f of x. And so let me erase this. So now each one of those signs are different. Now we have minus 2x squared, minus x, and then minus 3. I mean, plus x, excuse me, then minus 3. So we'll go back here. And now we can combine a like term. So what's supposed to happen is what's going to happen for us is that every term without h should cancel out. So we have 2x squared cancels. Then we have negative x, positive x that will cancel. And we have positive 3 and negative 3 that will cancel. And then this is what is left. And so if you do this correctly, then each term that's left will have h in it. And not only will it, but it must have h in it. Because normally, a lot of times when you're in calculus, what's going on is that h will actually be 0 or going to 0. So you do need that h to cancel out in the bottom. So that's why each term would need to have h in it. So we have 4xh plus 2h squared minus h all over h. Now that h can go into each term. That'll be 4xh over h plus 2h squared over h minus h over h. H's cancel out in the first one. Here, be careful. It was h squared. So one of those H's will cancel out, but still leave you with an H. And then H over H is 1. And that's your difference quotient. Questions? Any questions? I think I got one more, just to reemphasize the process. But any questions on what we've done up to this point? All right, scrolling up. So this one, we got f of x equal to 3x plus 7. So it doesn't have as much, so it's less involved, but I still would just emphasize the process. Want to find a difference quotient of 3x plus 7. So once again, they give us f of x. The first thing we want to do is to find f of x plus h. So we plug in x plus h in for x. All right, so that's 3 times x plus h plus 7. Distribute that's 3, that's 3x plus 3h plus 7. All right, so then subtract them like we did before. So we have 3x plus 3h plus 7, which is f of x plus h. And then we're going to subtract 3x plus 7, which was f of x. Distribute that negative. And that'll give us 3x plus 3h plus 7 minus 3x minus 7. All right, combine your like terms. 3x minus 3x cancels. Go ahead. 7 minus 7 cancels. That leaves you with 3h over h. H is canceled, and that'll leave you with 3. All right, any problems, any concerns? All right, that's it for 2-2. Something, yep, 2-4. Yeah. All right, so we're gonna stop right here. That's 2-2. Only reason I'm doing that is because of our positioning. I'm trying to give you guys a chance to get caught up and get to a good place. Because we still have time that we could go into another section, but like I said, I'm gonna give you guys a chance to go ahead and get caught up without me throwing another section at you. We'll pick up here at 2-3 on next class. Like I said, for those who didn't get a chance to finish this Sunday, I'm gonna open up the stuff. Well, last Sunday, yeah, the Sunday just passed. I opened up the due dates. Um, let's see, to this Sunday, and
I
I
thought
hope
it
you.
was our original due date. Was the
Huh?
original due date was the 20th.
Oh, I thought. Okay, I'm thinking about another class. Oh, y'all still got time then. Okay, we good then. We good. Yeah, because I was thinking y'all had. 'Cause I was like, man, a lot of people behind, man. I must have been rolling. So, look, in my defense, this whole weekend was a blur. If y'all saw my email, then y'all already know. So, yeah. So appreciate that. Appreciate that. So I would have went in there like, hey, man, ain't nobody tell me I was wrong, but appreciate it. So, that's cool. But we still can pause right here. Next class we'll do 2, 3, maybe 2, 4. We'll see. But I know we'll get 2, 3 knocked out. And go from there. Did anybody have any questions on anything? Anybody trying anything get stuck? I know I said that earlier, but I just want to make sure I open up the floor again, make sure everybody's good.
This section gonna be a beast.
This one right here? Well, I kind of felt it, so that's why I didn't want to go ahead and throw too much at you at one time. So yeah, so y'all sit back, digest it, see see if any questions pop up. And most definitely the floor will be open for questions on next class as well. Anything else? Anybody else? Everybody good? Everybody straight? All right. So I will see you guys on next class. Have a good one, and talk to you soon.
You have a good week.
Thanks, you the
Have a
same.
good weekend.
Thanks.
Thank you. Have a nice one.
Hey,
Bye, Professor.
take care.
Okay, so about my math lab, I really have no idea why I can't get in.
Mm-hmm.
So
Let me
it
stop
says,
the recording real quick.
okay.